If you landed in this video, chances are very high that you ran into an article on DevOps, or someone at your work mentioned about Terraform and infrastructure as code, or you are someone who wants to learn something new today. So in this video, I am going to explain what Terraform is, how Terraform works, and I'll touch a little bit on Terraform architecture and some basic Terraform commands. All right, let's try to learn what Terraform is. Developed by HashiCorp, Terraform is an open source declarative language to create, manage, and automate the provisioning of infrastructure resources like virtual machines, containers, databases, etc., using the philosophy called infrastructure as code. Terraform is vendor-agnostic tool and can manage infrastructure components for multiple resource providers like Google Cloud, Microsoft Azure, Amazon Web Services, etc. To understand it better, it is important to know the issues with traditional approach. Imagine in an organization, if someone wants to get a server or an infrastructure component like virtual machine, database, they have to follow a sequential process like opening a ticket on ServiceNow, getting reviewed by IT team, getting reviewed by information security team, and finally, the operations team will provision that infrastructure component. This is great, and it works fine if requests like these are limited, and provisioned infrastructure components have to live for years without you making any changes. But that's not the case. As organizations are transitioning towards the cloud, there is an increasing demand for elasticity in infrastructure. You have to have the flexibility to scale up and scale down as fast as possible based on the business need. Another major problem with traditional approach is configuration drift. What works in lower environments might not work in higher environments. This is because the legacy approach leverages point and click approach, which is prone to human errors. So the philosophy of infrastructure as code is to codify this exact process and automate it. I can execute a script to spin up a virtual machine. I can then reuse the same script in future, which essentially gives me the consistency and extensibility. Moreover, I can get my script checked into version control system where I can collaborate with other team members. As I can see the incremental history, this gives me the traceability and transparency in documentation. See how Terraform works. I'm taking Google Cloud Platform as an example to demonstrate. In this case, I'm inside a project of Google Cloud Platform where I wanted to create a virtual machine. I would start navigating to compute to create an instance. As you can see, there are several different input elements where I have to manually type and select configuration to my virtual machine. This is called point and click approach, in which documenting the series of steps is highly unlikely. This is exactly where Terraform comes into picture, where you define everything that you're doing here in console, and Terraform runs API calls to Google Cloud Platform, essentially communicating through APIs and creating the infrastructure. Since all major cloud platforms are driven by APIs, everything that we put as inputs in console is driven behind the scenes through API calls. Let's get some high-level understanding on Terraform architecture. Terraform architecture consists of three major components. 1, Terraform Core. 2, Terraform Configuration file. 3, Terraform State file. The first step is to write down our configuration in Terraform Configuration file. So this is where we define what are all the different infrastructure components that we need for a specific infrastructure requirement. So once we define our infrastructure components, we run Terraform apply, which then communicates with Terraform Core and creates a Terraform State file. So Terraform State file has all the information regarding what infrastructure component that this configuration file has been defined and where it is going to create these infrastructure components. And once the state file is created, Terraform Core then communicates with the cloud provider to create those infrastructure components. In this case, I'm creating a virtual machine in Google Cloud. Let's just say we wanted to create another infrastructure component, which is storage bucket. What we are going to do is we are going to define another resource block in our Terraform configuration file and execute it. So in the second iteration, Terraform Core checks the Terraform State file to see if there are any changes in the existing configuration file. Since there is a delta, which is the change in configuration, meaning we are adding a new infrastructure component, which is storage bucket, it is only going to create the storage bucket. State file in Terraform is very crucial because it is where the state of a typical infrastructure environment will be captured, and this is used for collaboration between teams. So state file should be securely stored in a safe location, but should not be checked into a version controlling system. Now that we understood the basics of Terraform and infrastructure as code, let's see some Terraform in action. In the next few minutes, I'm going to create a virtual machine completely through infrastructure as code using Terraform. So a typical Terraform configuration file will have a provider block and a bunch of other resource blocks. So since in this example, I'm only going to create a simple virtual machine, I define my provider block as Google and my resource block as Google Compute Instance. For Terraform to communicate with Google Cloud Platform, we first need to create a service account key in a Google Cloud project. So I'm going to go in IAM and admin section and select service accounts. We have a couple of service accounts created, so I'm going to select one and create a new key. I'm going to select the recommended JSON format for key and hit the create button, which will download a service account key into my local machine. I will then copy this key into a folder and open it from Visual Studio Code. Let's create a Terraform configuration file, and I'm going to name it as man.tf. Now let's define the provider. In this case, we are trying to create a resource in Google Cloud. So I'm going to define it as Google. And I'm going to define the parameters like credentials, project name, zone, and region in provider block. For credentials, we need to give the file path for the service account key that we just downloaded from Google Cloud Project. In this case, I'm going to name the Terraform Explorer, which is my service account key name. For project name, I'm going to copy paste the project name from my Google Cloud console, which is Terraform Explorer 1. For region and zone, I'm going to pick US Central as region, and for zone, I'm going to pick US Central 1A. Let's define the resource block. In resource, since we are creating a Google Compute instance, I'm going to name it as Google Compute Instance, and the name of this resource as VM Instance. Next, I'm going to define the name for this virtual machine. I'm going to name it as Terraform Project Dev VM. And I'm going to define the machine type as E2 micro instance. Next up, I wanted to initialize my boot disk with Debian image, so I'm going to declare it now. Another required parameter for creating a virtual machine is to define a network interface. So I'm going to give it as a default network for this particular virtual machine. And that's it. That's what's required for creating a very simple virtual machine. So we have our provider block and we have a resource block. Let's go ahead and run some basic Terraform commands. The first command I would do is Terraform init, which initializes the repository with necessary plugins and backend systems for this particular configuration file. As you can see, Terraform has been successfully initialized. If you observe the Explorer section, the Terraform folder and Terraform lock file has been created, which is where the plugins have been downloaded and installed. Next up, we are going to execute Terraform plan. Terraform plan essentially gives you a speculative plan of what's going to happen when you deploy this infrastructure. So if you see in my terminal, it's actually showing us a bunch of parameters with the information that I've provided in my configuration file. Also, you can observe that there are certain parameters where the values of those parameters is referred to as known after apply, meaning once you apply this infrastructure, these values to these parameters will get populated. So I'm going to bring the console and my Visual Studio Code side by side so you can see how this gets reflected once I execute Terraform apply. So I'm going to go ahead and execute Terraform apply and see towards my left screen how the new infrastructure gets created in my Google Cloud project. Terraform is asking if we wanted to perform these actions, so I'm going to type yes and hit enter. Terraform is now communicating with Google Cloud Platform and trying to create this virtual machine. So as you can see, it says the apply is complete and one resource added into my infrastructure. So I'm going to refresh my Google Cloud Platform console to see if these changes have been reflected in my virtual machine section. I'm going to check in the virtual machine instance section to verify if there is a newly created VM instance. As you can see, there is a newly created instance with the name exactly how we defined in our configuration file. And this is, we can double check this virtual machine name in our Terraform plan as well as in our Terraform configuration file. Name reflects in our configuration file at the same time in the speculative plan that Terraform has given us when we ran our Terraform plan command. So to double check if everything is looking good, let's see if this virtual machine has the disk Debian 10, which is exactly what we define in our configuration file. So I'm going to click on VM instance and check the image. There you go. So it says Debian 10. Now that we understood how infrastructure components can be created using Terraform apply, Terraform plan commands, let's go ahead and examine how we can destroy or delete infrastructure components using Terraform. So I'm going to go ahead and type Terraform destroy and hit enter. So now it's going to give us again a speculative plan saying these are all the resources that I'm going to delete. And yes, I'm going to validate that I wanted to delete and destroy these infrastructure components. And within minutes, it is going to destroy or delete all the infrastructure components in my configuration file. Within seconds, it's going to communicate with Google Cloud Platform, and the process of deleting the virtual machine gets kickstarted. So if you see now, the status of my virtual machine is processing, meaning behind the scenes, it is trying to delete this virtual machine. In a couple of minutes, this virtual machine will be deleted. And technically, we were able to create and destroy a virtual machine in Google Cloud Project without point and click approach, and everything with Terraform infrastructure as code. As you can see, my terminal, it says destroy complete, and one resource is successfully destroyed. Let's go ahead and refresh my Google Cloud project and see if this VM exists. And there is no VM anymore, so we were able to delete it.